Hello Explorers, today we're going to use our PocketLab and this giant syringe to help us understand the relationship between volume and the air pressure that we can monitor using our PocketLab pressure graph. We're going to use those observations to really try and think about what is happening at the molecular level when the air pressure increases and when it decreases. Use that knowledge to help us think about how an altimeter works. And then we're going to take it another step and think about how all of this relates to the ideal gas law. So let's go ahead and get started. For this lab, you'll need your PocketLab, a device to measure the data with, and a syringe large enough that the PocketLab can fit inside. Okay, so for this lab, go ahead and remove the plunger from the syringe, and then place the PocketLab inside the syringe. Make sure you have the pressure graph activated, and then you can just have your students or kind of play around with the syringe a little bit and just notice how as they just move the syringe back and forth, that will somehow change the pressure inside the syringe. And you want them thinking about what that's doing to the air molecules. It's kind of pushing them together. And then because the syringe isn't sealed, it keeps going back to whatever the air pressure is in the room. So what you can then do, and once you get into the lab, you'll do this, you'll want to seal the syringe so that we have sealed the amount of air molecules inside the syringe. Now, as I push the syringe in, you can see that's increasing the air pressure inside the syringe, and then you can get your students to think about why is that, what's happening. Well, it's because I am taking all of those air molecules and they can't go anywhere, they can't leave the syringe. So what I'm doing is I'm compressing them together, I'm pushing them closer and closer together with this force. This force is pushing them together. When you get them to think about how that relates to altitude, okay, you can have them think about how gravity is pulling all these air molecules down toward the surface of the Earth. So towards the surface of the Earth, just like you're putting a greater force into the syringe to increase the pressure, the force of gravity is pulling down all those air molecules, and you have a higher pressure lower in the atmosphere. Now, what you can also do to lower the atmosphere, or to not lower the atmosphere, lower the air pressure, push the syringe all the way in, and then seal it. And now when I pull back, what I'm doing is I'm taking there's a certain amount of air molecules in here when I seal the syringe, and so as I pull back the syringe, those air molecules, the gas inside the syringe rushes to fill the empty space, and so around the PocketLab you have less air pressure because those air molecules are not as densely packed together. Okay, so let's take a closer look at the data. So in the first graph we see that we took the syringe, and when we sealed the syringe and decreased the volume, what happened to the pressure? Well, the pressure went way up, went all the way up from 1,000 millibars all the way up to 1,703 millibars. So as volume decreased, pressure increased. So this relationship, this inverse relationship, will be important if you are using this to come up with the ideal gas law. Here on the other side, we see more evidence of that. Again, we started at about 1,000 millibars, and what we did this time when we sealed the syringe is we increased the volume by pulling back on the syringe, and as a result, the pressure decreased. So again, that shows the inversely proportional relationship. So one thing, again, you want to think about as you push the plunger in, you are taking that fixed amount of gas that's in the syringe and pushing that all together, and it's getting more and more dense, and that's increasing the air pressure. Here, when we have that fixed gas inside the syringe, as you pull the syringe back, the gas is rushing to fill that space, and you get a decrease in pressure. Okay, so if we want to take this one step further and understand the ideal gas law, we're going to need to figure out how pressure and temperature are related. So I've pulled up the two-graph function here with pressure on top and temperature on bottom. I'm going to seal the syringe, and then I'm going to heat the gas inside the syringe with a candle and see how that affects the pressure. So go ahead and record the data and just place the syringe over the candle, and you'll see after a few seconds the pressure start to rise. So already the degrees in Celsius has just increased by a couple degrees, and you've seen a pretty big increase in the pressure already.
Okay, so let's take a closer look at what's happening in our temperature and pressure graph. So we see that the temperature started at 29.93 degrees Celsius. As we held the syringe over the candle, the gas inside the syringe, the temperature of it increased to about 33 degrees Celsius. So as temperature increased, what happened to our pressure? Well, it started out down here at around 1,000 millibars, and as the temperature increased, so too did the pressure, and the pressure gets up to about 1,023 millibars. So as temperature increased, pressure increased. So let's think about how we can use our relationship between pressure and temperature and our relationship between pressure and volume to come up with the ideal gas law. So first, let's look at these relationships. Well, pressure is directly proportional to temperature, and we saw that in our graphs. And again, we can also think of that, and that makes sense, because what is temperature really a measurement of? It's a measurement of the average energy of the particles in the volume of the gas in this case. And so as the temperature is increasing, what's really happening is those particles are moving around with greater energy, which means they're pushing against the walls of the syringe and the PocketLab inside the syringe with greater force, which is increasing the pressure. So, how is pressure related to volume? We saw from the first part of the lab that pressure is inversely proportional to volume. So now we can use these relationships to get your students to start writing an equation for pressure. So they'll start with pressure is equal to temperature times a couple other things divided by volume. So what goes here? What are we going to multiply temperature by? Well, temperature is again the average energy of the particles inside the volume, but how many particles are we talking about? So the more particles we have, the more pressure we're going to have. So we need to know the number of particles inside the volume, and that's going to be, and we're going to think about that with the number of moles inside that the gas inside the syringe. So we can think of that as the number, kind of the number of particles. So we'll call that N, and then we're going to multiply that by a constant, which will be R, which is the universal gas constant, and that number is there to help us with the conversions to get all of these converted in the right way. And so now we have this equation here: P equals T temperature times N, the number of moles, the amount of gas, times R, a constant, divided by volume. So let's get volume. Let's get rid of volume on this side of the equation, so that you would just have your students multiply both sides by volume. So these would cancel out, and you'd end up with Vp equals T in R, which is more commonly written as the universal gas law, PV is equal to N R T.